Okay, a painting was purchased for €33,000. If it depreciates in value by 4.5% per annum, what value would it be in 5 years' time? Correct to the nearest euro. Okay, so what we're going to be doing here is we're going to be using a compound interest or compound basically appreciation. So if we use this formula here, so what we're going to do is cut and paste this over. Okay, so the formula reads it basically is increased continuously. Okay, so what happens is so a painting was purchased at 33,000. If it appreciates in value by 4.5% per annum, what will its value be in 5 years' time? Correct to the nearest euro. So its initial value is P. P is the initial value. I in decimals is the percentage, so that's going to be 0.045 because that's in decimal form, and T equals 5. So you're allowed to use this formula here if the interest rate. You're not allowed to use it if the interest rate is changed during the period or money is added or subtracted during the period. Now we can see that this doesn't happen at all in this question. So what we can have is that our final value, which is F, equals 33,000 multiplied by 1 plus, now the I value being 0.045 to the power of 5. Then we just need to put that all into the calculator, so it's going to be 33,000 multiplied by, it's going to be 1.045, because when we add the two of them together to the power of 5, and what we can find out is that this answer is going to be 41,124. So 41,124 euro. Okay. Now the next one is in 8,500 is invested into the savings account where the interest is compounded continuously with an annual rate of 2.8%. Calculate the future value of this investment in 3 years. Now compounded continuously means a different type of. So what compounded continuously means is that sometimes the interest is compounded continuously. In this case, the compounding period becomes infinitesimally small, and so the growth rate is exponential. So basically, as you go on and on and on, it goes upwards. Okay, exponential growth. So your final value equals your initial value, which is principal, by e to the power of RT, where R is the rate in decimal form. So R equals 0.028, T equals 3, and P equals 8,500. So what we're going to have for this one is F equals 8,500 multiplied by E to the power of R, which is 0.028 to the power of 3, multiplied by 3. So we need to just put that straight into the calculator, 8,500. Then we press Shift E button. That's going to be 0.028 all multiplied by 3. And then what we get here is 9,244.85. So the final value is 9,244.85. Okay, so that's question 6 done. Now for question 7, if F equals the principal plus multiplied by 1 plus I to the power of t, express P in terms of F, I and T. So F equals P by 1 plus I to the power of t. Bring down the 1 plus I to the power of t such that P equals F divided by 1 plus I to the power of t. Now hence or otherwise, what sum of money will have a future value? So what sum of money invested? So we're looking for P. So the question is to find out what P is. Okay, when it has a future value, so it has a final value of 88,578.05. In 6 years, T equals 6, 10% per annum, I equals 0.1. Okay, so put it into your formula. We're going to have 578.05. Then we're going to divide that all by 1 plus I to the power of t, which is going to be 1 plus 0.1 to the power of 6. So it's basically 1.1 to the power of 6 on the bottom. So it's basically 1.1 to the power of 6. Okay, so let's find out what this number is. 88,578.05 divided by bracket 1.1 to the power of 6. We get is 50,000. So it's equal to 50,000 euros worth of money. We'll do that. Okay, so that's question 8. Now we're on to question 11. Okay, what sum of money to the nearest euro will have a future value of 1,300 in 2 years at an AER of 4% if the interest is compounded continuously? So if it's compounded continuously, so once again, if it's compounded continuously, we're going to be using this formula here. Okay, so we have our F value is 1,300, our T value equals 2, our R value equals 0.04, and what we're looking to find out is what is our P value. So what we get is 1,300 equals P, E, now RT is R multiplied by T, which is going to be 2 times 0.04, which is 0.08. Now what we can do is we can divide that, so we're going to get P equals 1,300 divided by E to the power of 0.08. So 1,300 divided by E to the power of 0.08. What we get here is 1,200. So 1,200. So 1,200 euros the answer. Okay, so moving on. 15. 8,000 euros invested at a rate of R% per annum. In the future, value of investment in 3 years' time was 8,741.82. Calculate the value of R. So remember, the future value equals the principal 1 plus I to the power of t. Now I is the decimal form of the rate. Okay, so we have F is equal to is 8,741.82. We have P, which is going to be 8,000. Then we have 1 plus I to the power of t, and the power of t is 3 years. T is 3. Now, first things first, we're going to divide 8,741. So the 8,741.82 gets divided by 8,000. Okay, and we get this number here, so 1.09. Now don't get rid of any of these numbers. 1.09 272.75. 272.75. Okay, now this equals a number that's multiplied by itself 3 times. We need to find out what this number is. So when you bring 3 over to the other side, it's going to be this number to the power of a third, or the cube root. So what we can do is we can find our answer to the power of a third, and what we find out is that this is 1.03. So 1.03 equals 1 plus I. I therefore has to equal 0.03. Okay, so that's number 15. Now we're on to number 18. 18. 7,500 was invested at a rate of R% per annum, compounded continuously. So remember, the compounded continuously formula is F equals P, E, R, T. Now, P equals 7,500, F equals 9,345.58, T equals 4, and finally we're going to put them all in, so we're going to get 9,345.58 equals 7,500, and then e to the 4t. Now we're going to divide the 7,500 into the 9,345, so 9,345.58 divided by 7,000. What we're going to get there is 1.335, okay? So 1.335 equals e to the 4t. Now remember what we can do to separate e from its power. We're going to ln both sides. Oh sorry, t is 4. Sorry guys, this is 4r, not 4t. Excuse me, t is 4, so 4r. So what we're going to get is ln both sides. And then we're going to use the power rule. So that's going to be 4r ln e. And ln e is 1, so 4r equals ln 1.335. And then r equals ln 1.335 all divided by 4. So what I'm going to do is I'm going to save this big long decimal in my thing. I'm going to ln my answer. Once I've done that, I'm going to divide by 4. And I'm going to find out it's 0.0722. Okay, so this is question 18. Now, it didn't quite work out. Okay guys, so a quick error made here. It's actually 1.246. So the method is correct to the very end. 1.246 is the result of this here. And that's 1.246. And this part here is also 1.246. Okay, because we have these two numbers. Now, what we got to do is we got to get the ln of this answer. So it's going to be ln answer. And then we're going to divide this here by 4. We're going to get equals 0.055. R equals 0.055. This means R is 5.5%. Okay, that's the last two there. Okay, continuing on with 21. A woman borrowed €30,000 at 6% per annum compound interest. She agreed to repay 5,000 at the end of the first year, 5,000 at the end of the second year, and to clear the debt at the end of the third year. How much was paid to clear the debt? Well, what we're going to do is we're going to do a start and end. So here's the start, this is the end, and what we'll do is the years. So here is year 1, year 2, and year 3. Okay. We'll start off with year 1, year 2, year 3. So the start of year 1 you had €30,000 and then you added on 6%. So you multiply by 1.06. Okay, so 30,000 multiply by 1.06. And what we get here is 31,800. So at the start of the second year, so she agreed to repay €5,000 at the end of the first year. So we're going to take away €5,000 and we're going to start off the second year with 26,800. Once again, this 26,800 goes up another 6%. So you multiply by 1.06. So take away your 5,000. Now multiply this by 1.06. Because you're going up 6%. Now what we get here is 28,408. So 28,408. Now at the end of the second year, 50,000, another 5,000 is removed. So now we have 23,408. So remove our 5,000 again. And then finally, we're going to multiply this by 1.06, because the start of third year, you go through your full year, you get another 6%, so it's going to be 24,812 and 48 cents. Okay, and that is the answer for question 21. So that's how much you have to pay off at the end of the third year. Okay, so that's 21. And now we're going to do 24. A person invested €30,000 for 3 years at 5% AER. Calculate the amount after 2 years. Well, F equals P into 1 plus I times T. T equals 2 because it's 2 years. P equals 30,000 and I equals 0.05. So F is going to be equal to 30,000. Now 1 plus 0.05 is going to be 1.05 to the power of 2. That's going to be 30,000 multiplied by 1.05 to the power of 2. 33,075. So 33,075 is the figure at the end of the second year. After 2 years, a sum of money was withdrawn. The money which remained amounted to 26,250 at the end of the third year. Calculate the amount of money withdrawn after 2 years. So what happened at the end of this one is we have the final amount, which is 26,250. We know that T equals 1. We know that I equals 0.05. And we have to find out what did we put in at the start of the third year. So we have to find out what the P value is, okay? So remember, so it's going to be 26,250 equals P into 1 plus 0.05 to the power of 1. So 1.05p ends up to be 26,250 divided. So 26,250 divided by 1.05. What we get here is 25,000. So P equals 25,000. This means at the start of the third year we started with 25,000, which means that we removed, take these two numbers away from each other, and you're going to get 8,075 is the amount we removed to go from 33,075 down to 25,000. Okay guys, that's the end of this video.